Hello everyone, so in this video we are going to solve a question of LeetCode, that is minimum moves to equal array elements to. This is 462nd question of LeetCode and this comes under medium category. Alright, so let's start with the problem statement. Given an integer array nums of size n, return the minimum number of moves required to make all elements equal. And in one move you can increment or decrement an element of the array by one. Alright, so in this question basically we have given an integer array nums, and in this array nums we need to make all the elements equal. Alright, we need to make all the elements equal and we need to return the minimum number of moves, or we can say minimum number of operations required to make all the elements equal. And in the one move we can either increment or decrement an element by 1. Alright, so let's see the first example. In the first example we have 1, 2 and 3. So there are three possibilities. Let's say in the first example, if we make all the elements 1, if we make all the elements 2, and if we make all the elements 3. So there are three possibilities. So let's see one by one. In the first possibility, let's say if we want to make all the elements 1. So how many moves we need? Let's see. If we want to make all the elements 1, so to make 1 to 1 we need 0 operations. To make 2 to 1 we need to decrement once, so we need one operation. To make 3 to 1 we need to decrement 2 times, so we need 2 operations here. Okay, so altogether if we want to make all the elements equal to 1 we need total 3 operations. Okay, so for making 1 we need 3 operations. Alright, now let's say if we want to make all elements equal to 2. So to make all elements equal to 2 we need, let's say to make 1 to 2 we need one operation. 2 is same, let's write it 0, and for making 3 to 2 we need one operation. Okay, so altogether we need total 2 operations. Okay, so for 2 we need 2 operations. Alright, now let's see for the third case. In the third case, if we want to make all the elements 3, then for making 1 to 3 we need 2 operations, like 2 increments we need. For 2 we need 1 increment, and for 3 it's 0. So altogether again we need 3 operations. Okay, so in this question we need to return the minimum number of moves, or we can say minimum number of operation. So we can see that when we make all elements equal to 2, then we are needing the minimum operations. Okay, so what we can conclude from here? We can conclude one thing, that if the array is sorted, okay, if the array is sorted and we choose the middle element from here, okay, if we choose the middle element from here, then all the elements, if we just make equal to that middle element, the number of operations to make the elements equal to middle element is always the minimum. Alright, is always the minimum if we make all the elements equal to the middle element. So this is what we are going to do in this question. Alright, so let's see the approach. So the basic approach which we are following here is that we will be first sorting this array. Alright, first we are just sorting this array. So let me write here. The first step is we will sort this array. Alright, we will first sort this array. Alright, let's see. Let's take some other example. Let's first clear this. Yeah. So let's say we have 1, 2, 3, 4 and 5. We have 5 elements in an array. Alright, and we need to find out what's the minimum number of move to make all elements equal. So what we saw earlier, that first we need to sort this array. So the first step is sorting the array. So let's first sort this array. So it's already sorted. Alright, it's already sorted. So let's see the second step. In the second step, what we need to do is we need to find out the middle element. So what's the middle element? In this, the middle element is 3. Okay, the middle element is 3. So to find out the middle element, we will just divide the size of the array by 2. So that would be equal to n by 2. Okay, so in this case the middle element is 3. So let's say the size of the array is 5. So 5 divided by 2 is equal to 2. It is 2. Since the array is 0th index, so the 2th index will come on the 3. Okay, the 2th index will come to 3. So this is basically the middle element. Alright, now we have just found out the middle element. Now the third and the final step we perform is we will just find the absolute difference of all the values to find the minimum number of moves, because we can either increment or decrement. That's why we are just finding out the absolute value. Alright, so let's say in this example we need to make all the elements equal to the middle element 3. So if we find out the absolute value to convert 1 to 3, then it will be equal to 2. For 2 to 3 it is equal to 1. For 3 to 4 is equal to 1. And for 3 to 5 is equal to 2. So the total number of moves we need here is equal to 6. Alright, the total number of moves we need here is equal to 6. Alright, so I hope the approach is clear to you. We are just following these three steps. In the last step, we are just finding out the absolute value of difference. It is 3 minus 1. Alright, in this case 3 minus 1 or 3 minus 2 or 3 minus 4 or 3 minus 5. We are just finding out the absolute values here. So these are the three steps which we need to follow in this question. Alright, so I hope this is clear to you. If you still have any doubt in this approach, feel free to comment it down. Now let's move on to the coding part. So let's take a element int n is equal to num dot size. This will be storing the size of the array. Now let's take element mid. This will be storing the index of middle elements, that will be equal to n by 2. And let's first sort this array. So sort nums dot begin. Alright, nums dot begin and nums dot end. Now let's run a for loop to find out the absolute difference of all the values. So int I is equal to 0, I should be less than n and I plus plus. And let's find out the absolute value and store in the variable answer. So let's initialize the variable int answer is equal to 0, and answer will be updated here with the value of absolute value nums of I minus nums of mid. Alright, this is fine I guess, and let's return answer from here. Alright, yeah, it's working fine. Let's just submit it. Yeah, it's working fine. So let's calculate the time and space complexity of our solution. So the time complexity of our solution is like this: sorting function will take big of n log of n. Okay, this sorting function will take around n log of n, and this for loop will take big O of n. Alright, so altogether the time complexity would be equal to big O of n log of n. Alright, so let me write it here. So the time complexity of this solution is big O of n log of n. And now let's talk about the space complexity. So the space, we write it here. So the space complexity of this solution is big O of log of n. Okay, since this sorting function, we are storing the constant spaces here, so this would be big O of 1, but this sorting function will take around big O of log of n space to sort the array. Alright, this is the auxiliary space to sort the array. Since we are using C++ here, that's why the space complexity is log of n. this sorting function is taking log of n. But if you are using Python or any other language, then it depends on the language, because in Python the sorting function takes around big of n space. Alright, so it depends on the language. But since here we are using C++, though, so the space complexity in this solution is big O of log of n. Alright, so I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video, subscribe to our channel. I will see you in the next video.